Another day, another practice test. You know the deal. Unit 6, here we go. All these details you know by now. If you want to read through them more, go ahead and pause this. Now it's time to look at number 1. Of course, as always, I'm going to give you time to pause this and practice before I show you the word. Let's go. Number 1. The probability distribution graph shows the number of TVs per household. What's the probability that X is between 1 and 5? Notice there's no or equal to line here or here. So we are not including 1 and 5. And this is where your eyes should go. They should first go to the X values. X is the discrete random variable. We're first looking at X values between 1 and 5. There they are. Then we're finding the probability within that region. And we do that by looking at our probability values on the left and all of the bars in that box. So we have 0.4, 0.26, and 0.06 probabilities. Adding all three together, we get 0.72. Number 2, very similar, different layout. You got this. Okay. Using the probability distribution table, find the probability that X is between 2 and 4, but notice it's now including 2 and 4 as well. So first we look in the row with the discrete random variable, X, for values 2 to 4. But they want probabilities, so then we look at their associated probabilities, and once again, add them together. The answer is A. Number 3, the frequency table below shows the number of cups of coffee consumed per day. Use this information to create a bar graph. That's the main question they're asking you. That represents the probability distribution. Are these probabilities? That's my only question for you as you work this out. Hopefully you quickly answered no. F is for frequency, so we're not going to use these values in our bar graph, but we need them to help us. Remember this? We add them all together to get our total. Then we can find each individual probability. Before we do that, I want to make sure everyone understands what's going on in this table. Well, it's a frequency table. Frequency is how often is something happening. And what are we talking about? Drinking cups of coffee every day, okay? So in this study, where they asked people, how many cups of coffee do you drink per day? 0 people, or 0 cups of coffee, there were 183 people. For 1 cup of coffee, there were 109, and so on. Okay? That's what these values mean. To find the probabilities now, we add all the frequencies. We then find each individual probability. I set up a probability distribution table below. They didn't ask us to make a table, but you basically have to do this anyway, so why not? You take each frequency, divide by the total. Total is over here again, 500. Then we take the next frequency, 109, divide by the total, and so on. We do that for every frequency in the table to then give us every probability. And remember, you can check this by adding these up and seeing if they equal to 1. If they do, you did it right, because 1 is the decimal form of 100%, and all of the probabilities need to add up to 100% or 1 in decimal form. If your numbers are slightly off, it could be because there's 3 decimal places. Maybe you want to double check that, but as long as you're pretty close, you should be correct. But I would double check and maybe include a few more decimals to get it as close to 1 as possible. Now we have all the information we need, and it's time to make our bar graph. The x-axis are the x values, 0 through 4. Easy. When it comes to the probabilities, you need to determine which values you want to put on the y-axis by looking at what you have. Well, the highest value I see is 0.366. Now, I'd like some whole numbers in the tens place, and I don't want to use 2 3-decimal places. So I just figured why not go by 0.1, 2, 3, and then 4. And I decided to skip a little room because I thought, if these are too close together, it might be too difficult to read. Those are a few things I'm thinking about while I'm making this. And then, of course, you're looking at your probabilities to determine how high this bar goes. So 0.366 for 0, all the way up to 0.366 probability, and so on. 1.218 up to just over 0.2, and you get the rest. Give it a try. Use the frequency table provided, find the correct probabilities to complete the probability distribution table. There is no probability distribution table like we did on the last one, so basically you're filling in the blanks. I hope you realize this is pretty much the same as the last problem, minus the bar graph. Don't have to do it. Now, for these two problems on your practice test, if you're thinking, I don't need to do all this division, I could just do it on my calculator. I know you can, but there's more to it. So I do need you to show this work to get all your credit for your practice test. For example, I need you to show me that you know you're finding the probability of 5 by plugging in the frequency value and dividing by the total. There's a lot in there. And not only does it help me, but more importantly, it helps you. Those are all your probabilities on this one. Let's go ahead and look at number 5. Jake has a blue die and Taylor has a yellow die. The faces of the die are numbered both 1 through 6, like any regular die is, and both die are rolled at exactly the same time. The random variable x is the number on the blue die minus the number on the yellow die. That is the most crucial part of information. Blue die minus the number on the yellow die. Okay? And they want to know the probability of this. We don't even need to worry about that first. First thing we need to do is make a table. Okay? You should know how to make this table. I've already made it for you. And my question for you is, do you know where all these values come from? These are all the values of the random variable x, which is found by doing what? Taking the number on the blue die minus the number on the yellow. So we're taking blue minus yellow. 1 minus 1, 0. 1 minus 2, -1. 1 minus 3, -2, and so on. This happens over and over and over for every value in the table. So these are the possible outcomes, right? Because we have one die, the yellow die here, 1 through 6, and the blue die here, 1 through 6, right? And now we need to answer the question. What's the question? Find the probability that x is between -1 and 2. So where are we looking? We're looking between -1 and +2. All of these values. Or is it all of those values? Notice -1 is included, 2 is not. So it's not all of those. We're including everything from -1 all the way up to and not including 2. Those values. Count them up. How many are there? Let's see if you got it. There are 16. Remember, to find any probability, you put the favorable outcome, which is all of these x values, we counted them up, 16, over the total possible outcomes, which you could count every little box or multiply 6 times 6 to get 36. Simplify your fraction. The answer is 4/9. And number 6, which variable has a binomial distribution? There's lots of information in here. Let's highlight the question. And of course, the work is important, but what's equally important is knowing how to determine binomial distribution. It's what you see in the bottom corner here. I would write this down if I was you. You need to check if all 3 of these things are happening, and if they are, that's your answer. Yes, binomial distribution is happening, but you need to read these carefully. Think about them in the real world. These are all real world situations. Now is your time to give it a try. And if you're getting stuck, I'll work out A with you in a minute. Okay, let's do A together. If you still want to test yourself, but you need a little kickstart, let's read it. Over the next 5 days, X is the number of days it will snow. Okay. Is there a fixed number of trials? Yes, there are 5 days. A trial is an opportunity for the thing to happen. What is the thing they want to happen? Snow. So number 2, outcome of each trial is success or failure. Yes, snow or no snow. What does snow represent? What does no snow represent? Snow is success, no snow is failure. Right? They mentioned it's snowing, so they care about it snowing. And number 3, is the probability of success for each trial the same? Think about it realistically. So here's the deal. There are 5 days. We want to know if it will snow all of those 5 days. Is the probability of it snowing the same every single day? Absolutely not. That probability changes every day, right? So that is not going to work out. So A does not demonstrate binomial distribution. Now let me circle back to this number 3 for a moment, because a lot of people make mistakes there. If you were thinking, oh, the options are snow or no snow, just like heads or tails on a coin, so it must be a 50-50 chance, you're not thinking about this realistically. Realistically, the weather changes all the time, right? It's a natural thing. So it is not a 50-50 chance. I don't think I've ever seen a weather report where 5 days in a row have the exact same temperature, the exact same percent of snow or chance of snow or rain or anything else. Okay, so be careful. Go ahead now and try B, C, and D if you haven't already. Okay, the answer is D. We're going to go through all of these though, so you fully understand. We already checked A. B, a tennis player's probability of winning a match is 60%. X is the number of matches played to reach 4 wins. Well, X is the number of matches right away. This is not binomial distribution because they didn't tell us how many trials there are, right? They told us you can win or lose. That's obviously success or failure. And they did tell us the probability of winning is 60, so that's apparently going to stay the same. And they want to reach 4 wins, but they didn't tell us the number of matches. 4 wins out of how many matches? Okay. C, X is the number of ripe lemons selected from a bag of 10 lemons. When 4 lemons are selected without replacement, the probability of selecting a ripe lemon is 75%. Without replacement should automatically tell you the probability will change and you don't need to look any further. Now, that's for eliminating these, but I do want you to understand this as best you can. So what's going on here? They said 4 lemons are selected. Those are the trials. It's the event. It's the thing that's happening, right? And then the outcome of each trial is success or failure. Well, they're talking about ripe lemons. So success is ripe, failure is not ripe. And D, our lucky winner. A coin is tossed 8 times. X is the number of heads. Tossed 8 times, fixed number of trials. Heads or tails, success or failure. And it's a coin, like I mentioned before, right? It's always the same coin. You flip it, there's always a 50-50 chance of landing on either heads or tails. And that's why the answer is D. Now, we've made it through the first half of our Unit 6 practice test. Come back to get the rest.